Hi and good morning. So today we're going to discuss about circular functions of a unit circle. So before we start, the objectives for today is first, for us to define the six circular functions. Second, we need to apply the concepts of right triangle trigonometry to circular functions. Third, is for us to solve values of quadrantal and special angles. And lastly, is for us to solve problems using special angles. So let us just recall our Cartesian plane having the x-axis and the y-axis. Also, let's recall a unit circle. A unit circle has a center at 0, 0. So we have there at the right side the figure and a radius of 1. We have here having the radius of 1, the central angle. Let x, y be the endpoint of the unit of the circle of an arc of arc length s. The xy coordinates of this point can be described as functions of the angle. So on the figure on the right, we have here your x and we also have here your y. And if we indicate the angle inside, we call it theta. So let's start in a right angled triangle as shown on the right side. The side opposite the right angle is called the hypotenuse. If we choose one of the other angles and label it theta, the other sides are often called opposite, the side opposite to theta, and adjacent, the side next to theta. For a given theta, there is a whole family of right-angled triangles that are triangles of different sizes but are the same shape. Let's look the six circular functions based on the unit circle. So what are these six circular functions? So let's see, this is our unit circle and let's enlarge that. So we have there a right triangle having your x and then the y and then the radius and the theta. So what are the six circular functions? First is we have your sine. Recalling the trigonometric identities, sine theta is equal to opposite over hypotenuse. So if we're going to check this out, so we have here your sine over hypotenuse. So our opposite is, this is our theta. So our opposite would be y, and our x, our hypotenuse would be r. So therefore, sine theta is equal to y over r. Second circular function is what we call cosine. So trigonometric identity, we have cosine theta is equal to adjacent over hypotenuse. So looking at the figure above, our adjacent is x and our hypotenuse is r. Therefore, cosine theta is equal to x over r. Third circular function is what we call the tangent. Recalling the trigonometric identities, tangent is equal to opposite over adjacent. So our opposite once again is y and our adjacent is x. So therefore, tangent theta is equal to y over x. Fourth circular function is what we call cosecant. So recalling the formula of cosecant in the trigonometric identities, we have hypotenuse over opposite or 1 over sine theta. So our hypotenuse is r and our opposite is y. Therefore, cosecant theta is equal to r over y. Fifth circular function is so-called secant. Recalling the trigonometric identities, Secant is equal to hypotenuse over adjacent, or 1 over cosine theta. So our hypotenuse once again is r and our adjacent is x. Therefore, theta is equal to r over x. And lastly, our sixth circular function is cotangent. Recalling the trigonometric identity, cotangent is equal to adjacent over opposite, or that is 1 over tangent theta. Our adjacent is x and our opposite is y. Therefore, cotangent is equal to x over y. So these are the six circular functions based on the unit circle. So let's have some examples for us to apply the circular functions. Example number 1. What is the sine of an angle if a point on the terminal side of the angles is 1, 5? So what are the steps we need to do? Ba't niya? Layo na. Uh-oh. So let's have some examples for us to apply the six circular functions. Example number 1. What is the sine of an angle if a point on the terminal side of the angles is 1, 5? So what are the steps we need to do for us to be able to solve for the given? So first, step number 1 is for us to illustrate. Illustrate. So let's have some examples for us to apply the six circular functions. Example number 1. What is the sine of an angle if a point of the terminal of the side of the angles is 1, 5? So how are we going to solve for this? So step number 1 is for us to illustrate the given. So we need to illustrate the given by having the Cartesian plane. So let's illustrate. So it says there 1 and 5. So 1 would be our x and then 5 would be our y. So we will be having it, plotting it here. So we have here, if we will be having this here. So let's have it by 2. So if this is 2, we have here 2, 4, 6. So if we're going to plot there, 1 is here. We have here. And then we have 5 is in between here. So if we're going the intersection, so we will be having our point here. So let's illustrate our triangle. There you are. So we will be having this. Our x is 1 and our y is 5. So the angle is on the terminal side, so therefore this is our theta. Now, step number 2 is for us to calculate the value of our radius. So let's solve for the value of our radius. How are we going to calculate for the value of the radius is, we know that this is a right triangle. So we will be using the Pythagorean theorem. So if we're going to recall that, we'll be having your a squared plus b squared is equal to c squared. But in our case, our a squared is x squared plus y squared is equal to r squared. So let's substitute since r is missing. So r squared is equal to, our value for x is 1 quantity squared plus our value of y is 5 quantity squared. So r squared is equal to 1 times 1 is 1 plus 5 times 5 is 25. So r squared is equal to 26. But since we have squared, we need to square root, get the square root of it for us to be able to have r is equal to square root of 26 is the same as square root of 26. Now that we have the value of our radius, we're going to substitute already the given in our formula. So what is our formula? Since we are looking here, our formula, we are looking for sine. So therefore, sine theta is equal to, recalling ang formula natin ng 6 circular functions for sine is y over r. So let's substitute the given. So for our final step, or step number 4, is to calculate. So let's calculate the given. So we have sine theta is equal to, the value of our y is 5 over square root of 26. So let's simplify this. How are we going to simplify? Is to multiply both sides by the square root of 26 over square root of 26. So we will be having 5 square root of 26 over 26. So this would be our final answer. So therefore, sine theta is 5 square root of 26 over 26. Let's have example number 2. So let's have example number 2. We have here. Example number 2, find the second value of 4, negative 9 if it's a point on the terminal side of an angle in standard position. So first thing again that we need to do is to illustrate our given. So let's illustrate the given. So it says there 4, negative 9. So our value of our x is, so this is our, nakakainis. Isa pa. So let's have example number 2. Find the second value of 4, negative 9 if it's point on the terminal side of an angle in standard position. So first step again is for us to illustrate the given, on which we have here your 4 as x and we have your negative 9 as y. So our x is 4, so we have here 2, 4, so this is our 4, and we have negative 9, so we have here 2, 4, 6, 8, and let's have 9 here. Okay, so if we're going to have our intersection point, so we have it here. So let's draw. Sorry. So let's draw our right triangle. Okay. So our value of our x is positive 4 and our value of our y is negative 9. R is missing and our theta is on the terminal side, so therefore this is our theta. So next is we're looking for secant. So for solving for secant, first is the formula for secant is we have secant theta is equal to r over x. Since r is given, since we need to look for the value of r, so let's solve it again using the Pythagorean theorem. So we have r squared is equal to x squared plus y squared. So r squared is equal to our x squared is 4 quantity squared plus our 9 squared is negative 9 quantity squared. So r squared is equal to 4 times 4 is we have 16 plus negative 9 times negative 9 is we have 81. So r squared is equal to 16 plus 81 is we have 97, and then we get the square root of both sides. So we will be having r is equal to the square root of 97. So since we have the value of r already, so let's substitute to the given. So square root of 97 over the value of x is 4. If we could still simplify it further, then you may do so. But this already is the simplified form. So therefore, secant theta is equal to square root of 97 over 4. Example number 3. If a point on the terminal side of an angle is negative 3, 4, what is the tangent of an angle? So we're looking at, for today, for this problem is the tangent of the angle. So first is let us illustrate the given. So we have your value of x as negative 3 and the value of your y as positive 4. So if we're going to illustrate the given, so we have your x as negative 3. So we have here 2, 4. So our negative 3 here. And we have positive 4. So 2, 4. So we have here. So let's get the intersection of the two. So we have here. So let's have that already. Let's illustrate. Okay. So our x is negative 3 and our y is positive 4 and our radius. And the angle is on the terminal side. So there is the theta. Next is let us look for the problem. So we are looking for the tangent. So we have tangent theta is equal to, recalling the formula for tangent theta is we have y over x. Y over x. Since we do not need already the value of the radius, therefore all we need to do is to substitute the given. So our value for y is we have positive 4 and the value of our x is negative 3. Since we could not simplify this already, so therefore our answer is negative 4 over 3. The tangent theta is equal to negative 4 over 3. The joke mali. Thank you for listening and see you on our next chapter.